where I'm going to be joined by analyst Monica Paolini, the principal of Senza, Fili. Monica, hello.
Hi, Brian. Well, thanks for the introduction, and here we go. It's early in the day.
I'm glad to see you weren't sponsored. I didn't see any branding there, but at least you've got coffee. That's excellent. Now, I think you're going to talk about something really critical for service providers about the new spectrum frameworks. And I know this is a really critical area. So I'm going to hand the stage over to you. We're all looking forward to hearing from you.
Brian, thanks a lot. And Martin, thanks too to mention Motorola and Orthogon. I almost forgot about it. It was a long time ago, but it brings back a lot of memories. I have to confess that my first phone when I moved to the US was a Motorola, the one that you have the antenna that you just take out to get a good connection. And a long time has passed since then. And today we're back to, wireless is the new fiber. So it's an entirely upside down, when mobile used to be the exception and now it's the default. So today I'm going to talk about regulation. And regulation is the topic that a few years ago, when I would go to an event like this and it would be something about regulation, I would try to skip it if I could, because it would be sort of a boring talk. And this has changed recently. There is a lot of excitement in regulation. And to give you a sense of my background, I work on sort of the end-to-end network. So I'm not a regulatory person, so I don't do that full time. But what I do have to say, I do more and more work on regulation because it is so exciting. It's really, there is a lot of things going on there. So I hope you'll follow, not because I'm talking, but because it is quite an interesting field right now within wireless. And the reason for this is that there is a lot going on, and the overall role of the regulator is changed. It used to be that the regulator would be almost sort of a bottleneck. It's what you have to go through in order to have spectrum. And the regulator will be mostly involved in allocating spectrum either to specific users or to mobile operators, making sure it will keep up with the technology. Right now, what we're seeing is that there is a wider scope, and they're actually working much more actively with what the technology allows us to do to make sure that everybody has access to the spectrum they need, and that the users have the services they need. So it is a much more proactive and much more open role. And you can see here in the new regulatory branding at Ofcom, they're trying to promote choice, work on standards, and securing the networks. This is really important, and I will go through some of this, but it's important to keep in mind that one thing that the regulators are trying to do is to ensure that everybody has access to spectrum. And that means to make spectrum affordable, to be able to share spectrum, to make sure that the whatever band and whatever incumbents have right to use the spectrum do not limit in an unreasonable way what people can do. And this will enable different services, and this is going to be particularly good for the fixed, I would say, non-mobile use of wireless. In fact, I personally stopped using the term mobile most of the time, because mobile, when you think about our connectivity on a daily basis, it's more the exception rather than the rule. Most of the time, as users or in IoT applications, everything is fixed. And oftentimes that kind of fixed connectivity is better served by a fixed network than a mobile network, and using wireless technology. And so it's something that we should really think about it, because oftentimes all we talk about is mobile, but mobile is actually not all that common. Anyway, so here there is a new environment. The regulation is responding to different demand. We're using connectivity more. new players, not just mobile operators, new use cases. Think about 5G. The technology is helping us, and there is much more over need to provide indoor, rural, and underserved coverage. Now, I'm going to go through this through my slides pretty quickly, but I'm happy to take questions afterwards. Now, the one thing that we need to realize is that the technology is a great enabler, but in of itself is really not sufficient to keep up our connectivity needs. We do need to have more spectrum, and we need to use the spectrum in a more efficient way, meaning sharing it, spectrum reuse. This is absolutely crucial. You cannot create spectrum, but you can use it better, and the technology allows you to do that, but it's not enough on itself. And so we need to have more efficient allocation of spectrum, and we need to encourage new spectrum users. This is like the enterprise other service providers. COVID is also changing, as Martin was saying. There's a lot of changes. COVID is changing the way we use it, and what it was really interesting, it was not so much that the usage grew. It did grow a lot, some, but not much. But what was very interesting is that the growth in the use of connectivity came from homes. So it was fixed that increased. So it was the increase. In fact, it was seen more in the Wi-Fi use. So residential Wi-Fi rather than mobile networks. Some mobile networks actually saw a decrease in traffic because people were going out less. So what this means is that residential connectivity is becoming more important, and residential connectivity also in areas outside big cities. And people are increasingly moving outside of the cities. If you look at the real estate market, you can see that. And it's quite interesting because they can work. Now we realize that we can work everywhere, not all of us, but many of us. And so there is this increasing need to provide connectivity everywhere, even in rural or less dense places. And it's not just providing a basic connectivity. You do need good connectivity because people might rely on connectivity for work, healthcare, education. So it's not just watching something on some video on YouTube or Netflix. And so this is really that changes. COVID is imposing changes in the short term, but many of those changes will continue in the long term. Now, let me see here. So there's more than COVID, however. It's not just COVID. There is a lot of interest for private networks. And here, what I mean by private networks is not just the network in the corporate enterprise. It's, as you see, it's harbors, it's agriculture, it's mining, is some communities. So it's really, the mobile operators play a crucial role and mobile networks. But it is important to think about connectivity in a wider context, where a lot of the people that control the real estate, that are other venues or enterprises, and I mean it in a bigger sense, do need to have their own networks, because you cannot expect mobile operators to come in and build it for them or pay for them. And so this is we're talking about industrial farming and all of that, and regulation is crucial in providing spectrum to those users. And traditionally, this has not really been done because there wasn't much in a way of demand, or there was demand, but for some very specific applications. Now the demand is growing very rapidly, and this is why there is an increased emphasis on localized and shared spectrum regimes. And I'm going to talk about it later. But basically, the shift is that instead of thinking about the national footprint, we're going the other way as well. And we need both of them. So we have, countrywide cellular licenses, unlicensed access, and then localized and shared access, where you can have a network that is very small, very limited in size, limited to the real estate control, to the control over the real estate of the entity. That's a huge change. And this is really what needs to happen to provide the connectivity that we need. Okay, so now this is another aspect. So from the enterprise point of view, we're seeing private networks. On the residential connectivity, we increasingly depend on wireless. So everything in the house, not just our phones, uses wireless for access. However, that doesn't mean that you use cellular, and 5G is not going to solve that. A lot of people think that once we have 5G, we're not going to need Wi-Fi. We're just going to connect to the cellular network. And I just don't believe that that is the case. Because we still need so much connectivity that it just would not be cost-effective, efficient, or affordable to have it provided by a public cellular network. Now, this graph here, this is my favorite graph. Shows you how much of the traffic, this is the global IP traffic, goes through Wi-Fi, and that percentage is not increasing. Unfortunately, Cisco is not updating these numbers anymore, but you can see the trend, and there is no reason to think that it's changing in the short term, and I don't think that it will change with Wi-Fi. Although some of the usage might be taken by 5G unlicensed, but fundamentally you do need to have, no matter what you do in terms of access, you do need to have a connectivity to the home to enable all those services. And one way to think about it is like public light, real light. And if you think about it, you have street lights, and it's very, very useful, but you're not going to keep the windows open to let the light coming from the outside in. You're going to have your own sources of light inside the house. And they perform the same function to bring light to you, to what you do, but it's just different. And I think that we're going to continue to have something where you do need to have that kind of connectivity to the home, and it's going to become more important because of the changes that I was talking about. So, it's important to have it everywhere because everybody needs it. So it's no longer something that you need to move to a new place in order to have good connectivity. You expect good connectivity everywhere. Now, what does it mean for wireless? I think that wireless might be the new fiber, but in a way, they will have to work together. So, and this is, I'm kind of like, I feel bad about how primitive this graph here is, but I'm trying to get across a very basic point. Right now, typically you have it's either wireless or wireline, the connection. And oftentimes, traditionally, you have a wireless ISP that is as wireless as you can. It's mostly wireless. A lot of the sort of backhaul is wireless, and that's perfectly fine. And in a lot of places you have a wireline because you have fiber or to the home. However, I think that moving forward with the technological advances, the dropping cost of the equipment, the increased reliability, the better performance, and the new increase in focus on millimeter wave, what we're going to see is that the last bit of connectivity is going to be wireless. So it's wireless to the home and within the home. Now, how far you go into wireless, that's going to be, that's going to depend on the environment, but it's a different way to think about it, so that you don't have a wireline versus wireless opposition. The question is that how can you get them to work better? What's the best way to get them to work together? What is the right balance? Okay, so I'm not going to talk much about this, but I want to point out a lot of the new technology ingredients that are making this possible. 5G, both as a licensed access technology and unlicensed, so NR and RU, Wi-Fi, the new versions of Wi-Fi, Wi-Fi 6, Wi-Fi 6E, millimeter wave, MIMO, beamforming mesh, and you will hear more about that. All of this allow us to have networks where you can manage interference and transmission much more efficiently, and you can do in real time. You can have different technology coexisting. This is really important. And what is that? What is I think that the greatest innovation in terms of fixed is coming from high frequencies. And traditionally, high frequencies have had a really hard time because of the, you can't reach as far, you have all sorts of issues. And I think that all those factors that in the past were sort of obstacles, bottlenecks, they are now advantages. Because if you cannot send your signal too far out, that means that it's easy to manage interference. It's easier to you have better spectrum reuse, and you can protect incumbents, so you can do spectrum sharing more efficiently. So everything that used to be a limitation is now becoming an advantage. And what that means is that a lot of the business case that used to be very difficult is now more easier to deal with. What that means is that in turn, this has an advantage for regulation, because that enables the regulators to take a different look and a different approach to high frequencies and in general to regulation. So we're seeing a move beyond a licensed versus unlicensed mode. There is more, there is sharing and different types of sharing. And I'm going to get to that in a second. And this is also, there is real-time, it's possible to have real-time or near real-time sharing platforms. You can allocate licenses based on location, and I'm going to talk about it later. Use it or lose it, needs-based licensing. So it's no longer just giving spectrum to an operator that is going to build a national network. Flexible fees so that its spectrum is affordable and priced differently depending on what you want to do with it. Then there's a push for secondary markets. So if you don't need the spectrum that you have licensed, you can allow somebody else to use it. And less restrictive access coexistence rules. I'm not going to have much time to go into that specifically, but that's also very important. And this is going to be, most of the impact of this is actually going to be, I think, on high frequencies. So now I'm going to spend the last few minutes that I have to talk about specific example and cases, and there is more. One thing is that has been, it's sort of a recent hot news, is CBRS in the US, where to some extent, surprisingly, the FCC has been moved pretty quickly on establishing a 3-tier access in the 3.5 band, where there are incumbents that have to be protected, and then there is licensed use and unlicensed use. Basically, it's not quite that way. The spectrum band is shown here, but no matter what, some of the band is licensed, but there's always at least 70 megahertz within the band that is going to be unlicensed. Now, the limitations of this approach, I think it's a very interesting experiment, and I think it will work well. However, it's rather complex, and it really works for the U.S. market. For not for the U.S. market, for this band specifically, given the constraints. And so it's rather complex because you need to have SaaS entities that are going to manage access, and they're going to give users access on a near real-time basis as needed, if they requested, and if the spectrum is available. So this creates a different entity in the process, and this it adds clearly complexity, but it also adds advantages because it allows the spectrum to be used more efficiently, because the SaaS will give access to those who need it, not just those who have the infrastructure, those who need it at that time. However, there is also the ESC infrastructure that is basically a different structure, just needs to be deployed to see who uses spectrum. So incumbents don't tell I'm using the spectrum, there is the ESC infrastructures that figures out who's using the spectrum. And that seems to me a little bit of an unnecessary complication. And we still need to figure out how to use, how different GIA users, the unlicensed users, can share spectrum. However, there is interesting going on, and here you can see that the PAL licenses have been issued recently, and most of the licenses went to mobile operators, and you can read all about it. The only interesting part was that utilities actually did bid for some of them in the areas where they operate, and they were willing to pay a lot of money for it. Sometimes this is seen as, the enterprises stayed out. And there were some wireless ISPs and other service providers, but they were not really the major players. I think that this is not really surprising, because since you can use it on an unlicensed basis, if you are a wireless ISP, or if you are an enterprise, you can just, you don't need a PAL license. You don't need a license. You can just use unlicensed. So I wouldn't take this as a sign that the enterprise or wireless ISPs are not interested. Now, let's move to Europe. Enough about the US. There are a lot of very interesting approaches in Europe, and what I really like about them is that they tend to be much easier, and the focus there seems to be more into getting the incentives aligned, so that there is an advantage to everybody to share spectrum. Spectrum sharing in the past spectrum sharing is nothing new, but what's changing is that the regulators are trying very hard to make sure that everybody is on board. Everybody has to gain something from it. And so in the UK, they have different models where some bands are allocated to enterprises or other enterprises, wireless ISP cities, where you basically say how much you need, and in terms of space, what is the area that you need to cover. You have to demonstrate the need, and you're going to keep the license. You can have a license at a very low cost outside of the auction. You keep it for as long as you need it, as long as you use it. And the other is to encourage the secondary market, so that if a mobile operator doesn't need the spectrum in some area, they are encouraged to lease it. This is particularly good for rural areas where in rural areas where the operators doesn't need it, and that can count towards the rollout requirements. Then in Germany, there are some bands that, the 3.7 to 3.8 megahertz spectrum in the 3.4 to 3.8 band that is, again, this is reserved for private enterprises. And in Finland, they are encouraging secondary market. The 6 gigahertz, and I'm running out of time here, so I'm going to go fast. That's a huge opportunity that is opening. It's available in the US and the UK right now, and it's going to be available soon in other countries, including Europe. This is going to bring a huge expansion in the spectrum available for Wi-Fi, 5G unlicensed, and in general for enterprise accesses. Now, finally, there is all the millimeter wave, and as I said before, this is really where there is a lot of changes. There's a lot of bands, and different countries have different focus on different bands. In Europe, 26 gigahertz is a huge thing. 60 gigahertz is also it's going to be really important because it's unlicensed in many parts. And here there is it's a huge potential and there is a combination licensed, unlicensed. And as I said before, it's really important and very powerful to address a lot of use cases, especially underserved markets and services. And finally, there is above 100 gigahertz, but that's, I guess, for the next year. So thank you very much, and I hope you have time to get some questions.
Okay, thank you very much, Monica. Yes, we've got time. One that we've had in that I need to ask you is, it says, how important is real-time and dynamic sharing in optimizing spectrum utilization, and is that better than localized access?
Okay, that's a very good question. It's a complex one as well. And
Sorry about that.
there's been a lot of discussion. If you talk to the CBRS people in the US, they will talk to you for hours on this. So the question is that, you know, sometimes if you have a more complex system, real time, clearly you have a better way to use spectrum, increase spectrum efficiency, because you only get to use what you need. However, there is a price to pay. And when you have let's say mobile operators or major operators, that's easier to do. You know, they can, they are more sophisticated. But when you get to a small wireless ISP or an enterprise, to have all that coordination can be taxing and add a lot of complexity. So I think that we need to really think about it. It's a trade-off. And probably you want to have both, depending on what you do and depending on the band. So I think that we're going to see a little bit of both. And we're also going to see more, I think, a management of coexistence, in improving in the coexistence at the local level. Now you can see that already when in the Ofcom and some of the local licensing, you need to have coordination at the local level, because, you know, think about it right now. Spectrum areas are much bigger. As you get smaller, you get many more areas where you have two users next to each other, right? So you need to manage the overlap. And so we're going to see the users will need to communicate with each other, coordinate with each other much more. And some of it can be mandated, but if you are too strict on the rules, then you increase complexity and you decrease the attractiveness of the spectrum. So I think it's a tight line we need to learn to manage better once we know what's going on and, you know, what works best.
Okay, Monica, thank you very much for joining us today. That was a fascinating insight to all these very important issues.
Thank you very much.